To change a wheel, part of a car can be lifted using a hydraulic jack. When the mechanic pushes on the handle, a force F1 is made to act on a small piston. This piston is in contact with oil as shown in the diagram. Now it tells you the force F1 is 100 newtons, so we'll just write it on the diagram. Again, there's no reason why you can't do that yourself. And the area in the small piston is 4 centimeters squared. Calculate the pressure acting on the oil. So whatever pressure is here, remember the oil is incompressible and the pressure will be transmitted through the oil. So we're just going to do a calculation to calculate pressure. Pressure is force over area. The force is 100 newtons and the area is 4 centimeters squared. And that gives you an answer of 25, and it's newtons per centimetre squared. So there's 1 mark for your answer, 1 mark for your 100 divided by 4, and 1 mark for your equation. The next question then says, if the area of the large piston is 10 centimetres squared, calculate the size of the force F2 which acts in the large piston. So you know the pressure now is transmitted throughout that liquid. So that pressure of 25 newtons per centimetre squared here is the same as a pressure of 25 newtons per centimetre squared there too. So all you have to do is another pressure calculation. And this time we're looking for a force. We're going to rearrange this. Force is equal to pressure multiplied by area. And the pressure we're using is 25 and the area is 10. So the answer is 250 newtons. 250. Alright, now you should see there that because the area here is 2.5 times here, that 2.5 times area here than it is there. So 2.5 force gives you 10. That then the force here is 2.5 times that of here. So that was 100, and the force here, sorry, you can't see that. This was 100, and now this is 250. So whenever your area increased by 2.5 times, so does your force. Answer is 250. I'll just show you where the marks go. 1 mark for that, 2 marks for this, and 1 mark for your rearranged equation, like that. Okay, now this next part is really to do with work done, and it doesn't just fit in here just as well, but I'm going to do it here anyway, and you can look back at this question whenever you're doing your work, energy and power questions. So the question is, it's still about a hydraulic jack this time, and it says, when using a jack to raise a part of a car which is a load of 1500 newtons, so it's this part here, a mechanic exerts a force of 40 newtons and moves the end of the handle a vertical distance, a distance of 20 centimetres. This causes a part of the car to be raised a vertical distance of 0.5 centimetres. So you pull a distance of 20 centimetres, but you're only raising this a distance of 0.5. By calculating the input work and the useful output work, determine the efficiency of the jack. So the input work is a work that the mechanic does. So input work is calculated using force by distance. So the mechanic uses a force of 40. And he's using a distance of 20 centimetres, and I'm going to use 0.2 metres here because we're going to get an answer in joules, and that gives you an answer of 8 joules. Output work is a work done on the part of the car. So this causes the part of the car to be raised a vertical distance of ½ centimetre, and we're already told that the car has a load or a force of 1500 newtons. So it's 1500 times 0.5. And again, it's in centimetres, so that is, I'm going to write down 0.5 by 10 to the minus 2. Or you could have written it as 0.005. And that gives you an answer there of 7.5 joules. We're just going to write meters in there so that you know that that's been changed to meters. So to get efficiency, efficiency is useful output work done in this case. Sometimes it's energy or sometimes it's power over input power, or sorry, input work done or energy. So that's 7.5 divided by 8, and that gives you an answer of 0.938. And you can convert that into percentage by multiplying it by 100%. So it's 0.938 multiplied by 100% gives you 93.8%, or you could round it up to 94. Now you would not get that answer marked right if you wrote 0.938% because you haven't multiplied by 100. So the marks are going there for your answer for this equation. There's 2 marks here for doing that and for doing that. And that's where your 6 marks go. You can't see that, I'm just realising. So there's a whole calculation there. I'll just repeat that maybe. Input work done is force by distance, and that's the work done by the mechanic, which is 40 by 0.2 metres, is 8 joules. Output work done is the work done on the car, which is 1500 newtons, multiplied by 0.5 by 10 to the minus 2 metres, which gives you 7.5 joules. Efficiency is useful output work over input work. That's 7.5 divided by 8, which gives you 0.38, or if you want to make it into percentage, that's 93.8, or round it up to 94%.